Hello friends, today we are going to learn the next part of Unit 1, that is measurement standards and design of gauges. Unit 1, these are the contents, and today we are going to learn types and sources of errors. To start with, let us first understand what is meant by measurement. In previous lecture also we have seen what is meant by measurement. Measurement is the process of determining or finding the size, quantity or degree of something. The principal dimensional measurement is length, secondary measurement is angle and curvature. Here you can describe the shape without describing the size, but you cannot reverse the statement. So let us learn errors today. Errors or error. Basically we will see the definition. What is meant by error? Error is the difference between the true value and the measured value of a measured quantity. So mathematically we can write error as error equal to true value minus measured value. The errors may arise due to the characteristics of measuring instruments, or the process of measurement may be influenced by the environmental conditions. While taking measurements with the help of different measuring instruments, several types of errors may arise. These errors can be broadly classified into two categories, namely controllable or systematic errors and random errors. Let us see one by one here, types and sources of errors. So systematic errors. Systematic errors are regularly repetitive and can be eliminated. They result from improper condition or procedure of experiment. These errors can be controlled and reduced if properly analyzed, so they are called as controllable errors. In simple words, the errors which can be controlled if proper care is taken, then those errors are called as controllable errors. Systematic errors can be of different types as follows. First one is instrumental error. What is meant by instrumental error? For example, a poorly calibrated instrument such as a thermometer that reads 102 degrees Celsius when immersed in boiling water and 2 degrees Celsius when immersed in ice water at atmospheric pressure. Such a thermometer would result in measured values that are consistently too high, because we are observing here the difference of 2 degrees Celsius. Next point, next type, observational or reading error. For example, parallax in reading a meter scale. Parallax error, it is sometimes called as parallax error also. Parallax is the displacement or difference in the apparent position of an object viewed along two different lines of sight and is measured by the angle or semi-angle of inclination between those two lines. See here I have given one example. We are observing a meter scale. Okay, we are going to find out some dimension, but the position of observer's eye, if it is at position 2, you please see the figure, then it is correct. But if the position of observer is at position 1 or position 3, then we are getting the wrong reading. So this type of error which is there, it is called as observational error or parallax error. Then third one is environmental error. Variation in atmospheric conditions, that is temperature, pressure and other factors at the place of measurement, lead to the environmental errors. An environmental error is an error in calculations that are being a part of observations due to the environment. Any experiment performing anywhere in the universe has its surroundings. from which we cannot eliminate our system. The environmental errors have different causes which are widening the passage of time, such as research works telling us, including temperature, humidity, magnetic field, constantly vibrating earth surface, wind and improper lighting. Then fourth one is stylus pressure error. Variation in force applied by anvils of micrometer on component to be measured result in different reading. So this is also one type of error, stylus pressure error. So this leads to the wrong results. Sometimes stylus pressure error, they are also called as support errors also. In case of long bars, at the time of support, they may cause bending due to their self weight or external load, and due to this, the error produced due to improper support is called as support error. Then fifth type is alignment error. This error is based on Abbe's principle. So Abbe's principle of alignment, which states that the line of measurement of measuring component should coincide with the measuring scale or the axis of measuring instrument. If coinciding axes are not in line, then this error, alignment error, is observed. Generally, cosine errors will be developed while measurement of a given job is carried out using a dial gauge or a steel rule. For example, I have shown here one figure. A steel rule or scale is used for measuring certain length, but it is not aligned properly. So due to misalignment, there is small angle theta in between the measuring scale and the measuring scale axis and the measuring instrument, axis of the measuring instrument. So it is going to cause a cosine error. Next one is, sixth one is elastic deformation error, or it is also called as support error. Long bars due to improper support or due to self weight may undergo deflection or bend. As shown in the figure, due to less or high distance between the supports, a long bar tends to deform. So this is deformation error. Now next one is contact error. See here, a measuring instrument is having two anvils and one curved object is to be measured. The thickness of curved object is to be that is, say, simply ring. A ring is shown in the figure whose thickness is to be measured. If the jaws of the instrument are placed as shown in the figure, then the error which is developed, see here there is a gap. The figure itself shows the gap. The error is developed and this is called as contact error. It is due to because of poor contact only. Next one, random errors. So random errors in experimental measurements are caused by unknown and unpredictable changes in the experiment. These changes may occur in the measuring instruments or in environmental conditions. Sources of random errors cannot always be identified. See, the case of random errors is more serious as compared to systematic errors. So possible sources of random errors are small variations in the position of setting standards and workpiece, slight displacement of lever joints in the measuring instruments or measuring joints in the measuring instrument. Examples of the causes of random errors are electronic noise in the circuit of an electrical instrument, Second one is irregular changes in the heat loss rate from a solar corrector due to the changes in wind. These errors generally cannot be eliminated completely. Third reason can be the environmental factors. For example, unpredictable fluctuations in the line voltage, temperature, or mechanical vibrations of the equipment. So these can be the factors which may lead to wrong readings, and this leads to wrong results. So these are generally caused due to such factors. So these are random errors. Let us see what are the differences between systematic or avoidable errors and random or unavoidable errors. Here, systematic errors or controllable errors, they are also called as avoidable errors, whereas random errors, they are also called as unavoidable errors. So first difference is these errors are consistent and repetitive in nature and are of similar form. This is the case of systematic or controllable errors, whereas random errors are non-consistent and accidental in nature. Systematic error occur due to improper conditions or methods of measurement, whereas random errors are inherent in the measuring system or measuring instruments. Systematic error, third point, systematic errors, except human error, all other systematic errors can be controlled in magnitude and sense. Whereas the specific causes, magnitude, and sense of random errors cannot be determined. It is unpredictable. Fourth point, systematic errors can be identified and reduced if attempts are made to analyze the reasons, whereas the random errors cannot be eliminated but the results obtained can be corrected by suitable action. Fifth point, the systematic errors include calibration errors, errors due to the variation in environmental conditions, variation in contact pressure, parallax error, etc. Whereas the random errors include errors caused due to small variations in the position of standard and workpiece, slight displacement of lever joints in measuring instruments, and other such inherent reasons. Last sixth point, the systematic errors. Regarding systematic errors, the statistical methods do not operate on systematic errors, whereas statistical methods only operate on random errors. So these are the differences between systematic, that is avoidable errors, and random or unavoidable errors. So with this we have finished with the errors and the different types of errors. These are the few references I have mentioned here from where I have got the data regarding this error topic. You can refer these references for your further reading also. Thank you very much.